These are the frequently asked questions for pre-calculus for the worksheet for section 4.1 on angles and angle measures. The first problem you had asked for was number 2. And number 2 says a central angle in a circle of radius r has a measure of theta radians. If the same central angle were drawn in a circle of radius 3r, its radian measure would be. This is really a visual one, and what you need to do is draw a circle. And like it says, it has a central angle in that circle with a radius of r. And we're going to label that theta. Now, the same central angle is drawn in a circle of radius 3r. So think about going 1, 2 more radii out. And draw another circle. And this is not even going to be close to a circle here, but you get the idea. So if the same central angle is drawn in that circle with radius 3r, the radian measure would be, well, that angle hasn't changed. It's still the exact same angle that it was before. So the radius doesn't have any changes that it makes when we're talking about circles of different sizes. And that's why this works, is because the radius and 1 radian of each circle work in concert with each other. If the radius is bigger, 1 radian, that arc length is bigger as you go around through there. And so those two things work together. And that's why theta stays exactly as it is. So same central angle, same radian measure. Next one up that was asked about was number 4. Number 4 says, which of the following angles is coterminal with 14 pi over 5? Well, in order to figure that out, you might start thinking in degrees, but very quickly what you need to do is change that thinking into the 2 pi mode, and that's because we need radians. If we have 14 pi over 5, what we need to realize is we need multiples of 2 pi for that terminal side of our angle to land exactly in the same place. So the visual here would be to think of 14 pi over 5 as 14/5 pi. And you realize, well, that'll go in there 2 4/5 pi times. So I need to go 1, 2 pi, and then another 4/5 of the way in order to get that angle drawn. And so I'm trying to figure out which of these angles would do the same thing if I thought of it that way as a mixed number. So we certainly could go through it and use that fact, but it is much easier to just think, all right, a full rotation, it has to land at the same spot. A full rotation is 2 pi, but this is a fraction, and it has a 5 for the denominator. So I'm going to need to multiply my numerator and my denominator by 5. And that would give me 10 pi over 5. And now I know I can either add or subtract multiples of 10 pi over 5. I can go ahead and start doing the addition and subtraction until hopefully I get one of the answers that I see up here. So if I do 14 pi minus 10 pi, just starting with the negatives first, 14 pi over 5 minus 10 pi over 5 would be 4 pi over 5. Now, that's not one of the answers up there, so I try again and again. What I am really subtracting when I'm subtracting 10 pi over 5 is 2 pi. I'm trying to get it to land at that same spot again. And so that would give me a negative 6 pi over 5, which, again, not one of my answers up there, but I keep trying and I subtract another 10 pi over 5, and that gets me negative 16 pi over 5, which is one of the answers up here. Now notice I didn't even go through the positive ones yet, but we certainly could and say 14 pi plus 10 pi would be 24 pi over 5, and we know that's not up here, and then you could go one more time and add another 10 pi over 5 to that, and you get 34 pi over 5. And you start to realize that some of these answers are just, they're not going to happen. You know, everything is going to stay under that common denominator of 5. And hopefully at this point you'd notice I'm well over 9 pi over 5. And that gets you into thinking, okay, now I have to do the subtraction. So those multiples of 2 pi are what we are always looking for. Next we have number 5. And this one is looking at reference angles when we are talking about radians. And so what we want to do is make sure that we're able to understand that whole pi system that we have with radians. So we want our reference angle, and how I would start is just by drawing a picture. And we would want to think of 32 pi over 9 as 32 ninths pi to get an idea of how many times this is going to go a full circle. So 32 divided by 9. 9 goes into 32 3 times. That gives you 27. So we would have 3 and 5 ninths pi for number 5. And you go to your drawing. And we have 1 pi, 2 pi, 3 pi, and now we need to go 5 ninths of the way across. And that's going to be more than halfway because 4.5 would be half of 9. So we're going a little bit over that with a 5. So now I realize this piece that I just had right here, that was 5 ninths of pi. And I want to get it all the way back up here to a complete pi. So if this was 4 ninths and I want 1 pi, I have to figure out, or this was 5 ninths, if I want to figure out what's missing, I could take 1 minus 5 ninths, which is going to give me 4 ninths. And 4 ninths pi, we can rewrite as 4 pi over 9. So 4 pi over 9 is answer B. And there it is. So again, a different way of thinking when you're in radians. When you have to draw it, it's a really good idea to think of it in terms of a mixed number so that you can figure out where 1 pi is as a straight angle and where 2 pi is as a complete circle. Next one you had was number 6. And number 6 says 2 angles are complementary if their sum is 90 degrees. In radians, find the complement of pi over 30. So what we really want is we want to know pi over 30 plus something, I'll just call it x, equals 90 degrees. But we notice this is in radians. So 90 degrees is pi over 2 in radians. Now if you don't remember that, you could go ahead and do the conversion and multiply it times pi radians over 180 degrees. And very quickly you'll notice, oh yeah, this is a 1 and this is a 2, so it's going to be pi over 2 radians. And now we're dealing with fractions, so it's up to you how you go from here. I actually just worked this completely with the fractions. I didn't do any multiplying by the LCD or anything like that, because all we really have to do is subtract pi over 30 from both sides. And to do that, we would need common denominators. So we would need to multiply this one by 15 on the top and the bottom, and we would have 15 pi over 30 minus 1 pi over 30, which would be 14 pi over 30, which of course we can reduce because both of those are even numbers, and we get 7 pi over 15, which is answer A. So you can think of it in terms of algebra. You know, you have something missing, you want to find it, set up an equation, and solve it from there. So number 7 is probably the supplementary problem, and you're going to see that that one is very similar. So in number 7, it says 2 angles are supplementary if their sum is 180 degrees. Find the supplement of 11 pi over 60. So we have 11 pi over 60. We want to add some angle in radian measure and get 180 degrees. Well, 180 degrees is a straight angle, and that's pi radians. So we want this to be pi. So we would have to subtract 11 pi over 60 from both sides. And again, because we are working in radians, we do need to think in fractions and say, all right, I would need pi over 1, but I need it with a 60. And whatever I do to the bottom of the fraction, I need to do to the top. I need that 60 for my denominator. So this is really going to be 60 pi over 60 minus 11 pi over 60. So what we need to do is really just take 60 minus 11. And when we do that, we're going to get the number that we need. And that's going to give us 49 pi over 60. We check to see if we can reduce, but this is one of the answers up here, so we don't even need to reduce. So again, what you need to do is just get used to the fact that we are going to be dealing with fractions whenever we talk about radians, but it is absolutely the best way to go mathematically because it is much more accurate than what we would ever get with degrees. Number 8 says find a coterminal angle to the angle of 137 degrees. So the first thing I would probably do is just get a feel for the angle by making a visual of it and realizing that 137 degrees, well, it's definitely going to go past 90, but not all the way over there to 180. So this is 137 degrees. I would want to know, what about this little chunk right here? Because what if they come at this on the negative side? I would want to know what that angle is going to be. And that little angle is 43 degrees. So these are things that I'm thinking about as I'm trying to figure out which of these is going to work. And first of all, I totally realize 43 degrees is out. You know, this is a counterclockwise movement. We're well past that with 137. That's not going to land in the same spot. Then we start our process of dividing by 360 to see just how many times all of these are going to be going around as we go through this. So for number 8, if we take this obnoxious number of negative 251,146 and we divide that by 360, we get negative 697.627 repeating forever. And since this is negative, we round up so we can get an idea of where exactly this would land. So we're going to round to 698 times 360, and we're going to see what we get. And that comes out to 134 degrees. Well, we don't need 134 degrees. We need 137 degrees, so B is out. We go to C. We divide by 360, and we will get 222.4416, where the 6 is repeating. But this is positive, so we would round down. So we'll take 80,079, and we will subtract 222 times 360, and we will see what we get. And that comes out to 159 degrees. Not what we needed. We're looking for 137. C is out. And we're getting the impression here that maybe we should have started with the last one, but I'll go with these in order as we go through them. So next one up, again, you divide by 360 to see how many full rotations we could get. And this is 555.40277 repeating. And with this one, it is positive, so we're going to round down. And we're going to take this monstrous number here, 199,945. And we're going to subtract 555 times 360, and we are really hoping it's 137, but it is not. It's 145 degrees. Pretty obviously it's E, but let me show you why. So what we need to do in E is the same thing we've been doing for all the rest of these. We're going to divide it by 360 and see what we get. So if we divide it by 360, it's negative 998.6194, blah, blah, blah. Well, because this one is already negative, what we want to do is we want to round this one up and make it 999. So negative 359,503 plus 999 times 360, because remember we're going to be subtracting a negative, it's just going to be addition anyway. And that comes out to, voila, 137 degrees. So made us wait till last there to get all of those to work. And really that is the way that we need to test these to see whether or not they are going to give us that coterminal angle of 137 degrees. Then, let's see what the next one was that you had on your list. Next up, well, number 9. Didn't have to go too far for that one. Number 9 says find a coterminal angle to the angle of 27 pi over 50. All right, so we're starting with 27 pi over 50. And what we have to do is remember that coterminal angles are adding or subtracting 2 pi. Well, since this is over 50, 2 pi over 1, we need to figure out what that would be over 50. And so that means we're going to go ahead and multiply the numerator and the denominator by 50, which makes this one kind of nice. Now, that's one way to do this. We certainly could, keep adding 100 pi over 50, keep subtracting 100 pi over 50. But really with this one, the easiest way to do this one is to change this into a decimal, which I don't recommend very often. But with 27/50ths pi, we're going to get 0.54 pi. And let me show you why this is probably the fastest way to do this problem. It's right here. Look at that bugger. I mean, if we keep adding 100s forever and don't notice, look at that. It's got a 27 at the end. That would be the quickest way to do this one, would be to notice, oh, it's going to have a 27 as the last two numbers when we go through this. So we already know that this is going to be C, but it's huge. So we would be here for a while if we just added and subtracted 100. So let's say you go after this in a decimal form because you don't notice the 27 there. What you'd have to do is convert these into decimals, like this one is 7.22 pi. And you'd have to think to yourself, okay, normally what I would do is figure out how many rotations I have here. But I always know that they come as 2 pi. So it would be 2 pi, 4 pi, 6 pi, 8 pi. I'm going to subtract 6 pi from this, and I'm going to see if I get that 0.54 pi. And of course I don't get it here. That's 1.22 pi. And that's not what I needed. I needed the 0.54 pi. Then I go to the next one, and because this one would be negative 48.78 pi, I realized the best thing for me to do would be to add 50 pi, always in multiples of 2 because that's a full rotation. And that gives me 1.22 pi, which, makes that coterminal with A, but that's not what we were trying to be coterminal with. We were trying to be coterminal with 27 pi over 50. So then our C, we put that into a decimal, 1396.54 pi, and we realized that we would take 1396 pi because that would be even, a multiple of 2, and that would give us 0.54 pi. And that is our answer. Now, if we continued this on, let's just say for some reason we didn't start with C, we didn't start with A, B, and C, we came at it from the other end. This would be 0.46 pi, and we would know that we would have to subtract 2 pi, which would be negative 1.54 pi, and that's not what we need. We need 0.54. And last one, this would be 1.46 pi as a decimal, and so we could subtract 2 pi from that, and that would give us a negative 0.54 pi, which again is not what we needed. We need a positive one with that. So, easiest way to do this one would be to notice if I'm just going to be adding multiples of 100 on the top, I just need the last two digits to be a 2 and a 7 in front of the pi. And absolutely see that C right away. But if you don't, I'm just showing you an alternate method, an alternate way to see those patterns. I do get to skip one of them here. I get to skip number 10. So, off to 11. Number 11 has draw the following angles in standard position, then find the reference angle. Be sure to show the terminal ray and label the reference angle in your diagram. So with this one, what we have to do to figure out where it's going to land is we have to divide it by 360 since this is in degrees. And because this one is negative, once we figure out what that is, we're going to have to round up. And with rounding up, that's going to give us 8. So we're going to take negative 2,587.62 degrees, and we're going to add 8 revolutions to that, which would be 8 times 360. And that gives us 292.38. But again, this angle was negative. However, when we talk about a coterminal angle, often we want to see a really nice positive value for that. So now what I have to remember is that I'm going 8 revolutions, 8 rotations around. So let's see if I can get 8 in there negative. All right, and then I'm going to need to land this at 292.38. So the other way to do this is to figure out the negative amount. So we could figure out, we've got our 8 times 360. And we added that to the negative 2587.62. But if we subtract 360 again for the negative, we would get negative 67.62 degrees. And that probably makes it a little easier to put it into the right position. And it definitely makes it a lot easier to see the reference angle, because that is the reference angle. So theta cotangent was 292.38 because we needed that to be positive. We want that cotangent. Coterminal would be 292.38. We need that to be positive. But theta reference, negative 67.62 degrees. It gets kind of carried away. All right, this one is 8 1/7 pi. So 1. All right, so I've got 4 rotations there, which brings me to 8 pi, and I need 1/7 more. So that is my reference angle, which is 1/7 pi. So theta reference is going to be pi over 7. C, same type of thing. Unfortunately, this is a big one when you divide it through. So 2,223 divided by 12 is 185 1/4 pi. And I want to get an idea of where that's going to land. So what I do is I divide that by 2 pi to figure out, how many of those rotations that I'm going to need. And I get 92.5, which is excellent, because that tells me I'm going to go 92 around, and then I'm going to land halfway across. So I already know this is going to be a straight angle.
Just a reminder, credit.
All right, now what I'm going to do is just make a big blob in the middle like we talked about in class, because this is big time, 185. I'm not going to sit here and draw 185 little spirals to get all the way back there. So theta reference, actually this one is phi reference. Phi reference for this one, because the initial angle was phi. We don't get one. It is on the x-axis, so we're just going to put none. It is its own reference angle. We don't have a reference angle when something lands on the x-axis. Then D, I'm definitely going to have to do some erasing here. We're going through the same process. So for D, the first thing that I need to do is I have to change this from degrees, minutes, and seconds to just degrees. And that comes from 1, 2, 3, 4, 5 plus 67 over 60 plus 89 over 3,600. And that gives me 1, 2, 3, 4, 6.14139. All right, so now that I have it in degrees, what I'm going to want to do is divide by 360 to figure out what I should be using as my number of rotations. And when we do that, we get 33 and some change, actually 34 and some change. And so we know that what we have to do here is round down and take that 34 times 360 and subtract that from this angle to figure out where it's going to land. And when we do that, that is 106.141. So we start on the positive x-axis, realizing 34 times, so we'll just kind of really go overboard here with this. And then what we have to do is put a little arrow, and we have 106.141, so we're going to have to go 90 degrees, not quite to 180, so somewhere in here with that 106.141. And I realize this is 180 degrees, so if I take 180 degrees and I subtract 106.141, that should give me my reference angle, which is 73.858 degrees. So beta reference, 73.858 degrees. All right, I'm going to go after E a little bit differently here. what I'm going to do is explain this in terms of revolutions, and that's because it seems like people are having trouble with these radians that don't have the label. So if we have 37.603 and we want to know how many times is that going around, we could take 37.603 and we could divide that by 2 pi. And that gives us 5.984703. So that means we will go around 5 revolutions. But we also have this portion of revolution right there. And each revolution is in 2 pi. So if we take our 0.984703 times 2 pi, we will get 6.187071422. That's a little hard to read there. 6.187071422. And we know that to get all the way around, we have to go 2 pi. And if we take 2 times pi, we get 6.28. So 6.283, rounding that to the 3 decimal places. So for the reference angle, what I want to know is what little chunk here do I need to leave out? You know, how much would complete this all the way up to the x-axis? So to figure that out, I have to take my 2 pi and I have to subtract this value. That's 6.187071422. And that gives me 0.0961. That is the radian measure that I need for my reference angle. So for this one, alpha reference is going to equal 0.096 radians. And I think that's a little easier to understand than the way that we had gone through that in class using the resources that I had. It just has to do with what percentage of the revolution do you want. And in this case, this is the percentage of that revolution that we need. So 0.096 radians would make more sense in this case. All right, number 12, convert it from DMS to decimal radians. Well, the first thing we need is decimals, and that means we have to convert this into degrees. I mean, it says to decimal radians, which means we want to figure out what we have here as far as radians go. That's a really weird way to put that. Basically, what they want us to do is take degrees, minutes, and seconds, just get it into degrees, and then change it into radians. So we have 118 plus 44 over 60 plus 13 over 3,600. And that comes from the fact that there are 60 minutes in a degree, and then there are 60 seconds in a minute. So that means that 60 times 60 gives us 3,600 for the amount that we would need there for seconds. And that would be 427,453 over 3,600. And because this is now in degrees, we have to convert that with pi radians over 180 degrees. And so the degrees here would cancel right out. And then we go ahead and do the math. And what they were saying was, give it to us as a decimal, not the pi part. Pi is always perfect and we leave it. But find this, then divide it by 180, or multiply across, and divide, and we will get 0.660 pi when we do that. So number 12 has a lot of converting going on, and we're writing our answer a little bit strange. So that's probably what messed with some people on that one. Next one up, number 13. Number 13 has us converting again. We are converting 6,341 pi over 17 from radians to DMS, so degrees, minutes, and seconds, and they just want you to show your work. So we have 6,341 pi over 17, and we want to go from radians to degrees, so we need something with pi down here in the bottom, in order to get rid of those radians. And then we need 180 degrees for pi radians, so that makes sense. And the pi's will cancel out. You'll need to take 6341 times 180 and divide that by 17. And that will get you 67,140 degrees. And it said we're supposed to convert this into DMS, but if that works out perfectly, then we're done. So let me double check their math here. 6341 times 180 divided by 17. It works out perfectly to 67,140 degrees. So we don't need any minutes or seconds on that one. Then next one up was number 14. Number 14 says, find an angle theta that's going to be between 0 and 360 degrees that would be coterminal with the following given angles. Oh boy, so this is very much like some of the earlier problems that we did. So what I need to do is think about, how many multiples of 360 that I'm going to need in here. And for A, I only need 2 of them. So when I do that, 744 minus 720, I'll get 24 degrees. So that's going to be theta coterminal. Next one up, we're going to have to do some division there. So you take your negative 5,381.251 and you divide that by 360. And what you get, you make sure you round up since this one was negative. So we're going to have negative 5,381.251 plus 15 times 360. And that gives us theta coterminal, which is 18.749 degrees when you do that. C, that's kind of a nice one, except, if we add 360, it's not quite enough. So we're going to have to add 720 to that one. And that gives me theta coterminal of 359 degrees. And then for D, what we would want to do is, again, we can just think of this in terms of 360 degrees. We don't really need to worry about the minutes and the seconds. We just want the coterminal part. And it says between 360 degrees, and whether or not we have degrees and minutes there doesn't make any difference. So 720 would be the closest that we have to that, and that's going to be 80 degrees, 25 minutes, and 25 seconds when we do that subtraction. And if you wanted this in degrees, you could go ahead and punch in 80 plus 25 over 60 plus 25 over 3,600. And that will come out to 80.424 degrees for number 14. And then the last one that anybody had asked for was in number 15. With number 15, part D, I'm going to go after this one a little bit differently than they did in the book, and hopefully it'll make a little more sense, or at least I should say on the key. The key was a little bit weird about this one. So find an angle alpha from 0 to 2 pi that is coterminal with the following given angles. This is in radians. And so the first thing I want to do is figure out how many rotations am I talking about, and that means that I need to divide that by 2 pi in order to make this work. And what I would do at this point, since everything was given in radians, is just go ahead and find out what that is. And that comes out to about 3.183. Now, what that tells me is that 20 radians, and it makes perfect sense when you think about it. If we're starting at 0 radians and we're at 3.142 over here, and then we go back over here to 6.284, we're talking about how many times that 20 is going to go around. So if we do that, it makes sense that we're going to see 3.183. If you take 3 times 6, you're going to get 18, and we're going to get a little bit more. So what we notice here is that we'll go around 1, 2, 3 times, and then we need to figure out how much we are really away from that reference that we need, which would be the x angle right here. And that's really what this is about, figuring out normally what is the reference angle. In this case will also be our coterminal angle. It'll be the same thing. So if we have 3.183 and we want to figure out what that really is when we're looking at this angle, the 3 doesn't make any difference at all because that was how many times we went around. What makes a difference is the 0.183 because that was what we had left. Now, we need to put this back into radians because we divided that out before by multiplying that by 2 pi to get that back. And so that would be 1.1498 blah, blah, blah. And we could go with 1.150 because of rounding and just leave it. That's in radians. And that's probably the easiest way for somebody to understand what's going on. So take your 20, divide it by that 2 pi because that's radians all the way around, and you'll see that you have 3 and a little bit of change rotations. So you're going around the 3 rotations, and then you have this little sliver of 0.183 that you need to figure out what it is. And to figure that out, we're going to put it back into radians by taking it times 2 pi to get what we need there, which is 1.150 radians. So that one a little bit odd. Again, whenever we're just dealing straight with radians and there's no pi, things get a little dicey.